and I never stop. It's been one crazy sort of discovery after another over the last 2 weeks, and I'm going through some kind of like I don't know, you ebb and flow in your ability to create things a little bit, right? And you go through phases where you're kind of, I'm not inspired to create anything and I'm just going to do, heads down. This is not one of those times. Like there was this compounding series of things, starting from graphs and GNNs and to the ability now to train LLMs in real time using a CPU, which actually works. No matter what the guys on Reddit say, it totally does work and you should try it. It's nuts. And yeah, it's just all this stuff's happening, at least for me. And I think I'm not sure if this is a byproduct of like Opus 4.5 being really good, or maybe just me being creative at the moment, a combination of both. I don't know, but lots, at least in my world, lots happening.
Yeah, no,
Um,
totally, Roof. I mean, you're going to experience it much more dramatically, of course. But I think what we're seeing is a reduction in the deception heuristics. Like the model's 4.5 seems to be much less prone to stuffing mock data and placeholders and subfunctions and faking results. So I think they put their finger on something very specific in addressing that with this new model. And it's personally for me, it's absolutely elevated the output and the quality of the stuff that we're doing. What?
Yeah, and I think the key here is it seems to be a compounding series of things that I've been doing. And one of the most important sort of distinctions to what I was building earlier in the year to what I've been building basically since the launch of Claude Flow in June is the idea of modularity of the things I can build and being able to easily reuse just parts of those things in different ways where Claude Code was essentially starting down that path with kind of modular. I've got the agent flow system, which is kind of the core intelligence, and I get agent DB, which provides the sort of vector and other sort of learning capabilities. I separate those things, and once I separated those things, I could independently kind of improve those things without breaking everything else in the process. And then moving a little bit more forward, I started breaking those into sub packages. And so it became much easier to sort of discover how the various pieces fit together in different interesting ways, which led to, the ability to update vectors. And that said, I don't think very many people in the world have created a vector database from scratch, vibing it anyway. So that actually seems to work and is now adopted by thousands in like a week and a half. So, it's weird times we live in for sure. All right, we have some housekeeping, right? We're working on the upcoming hackathon tomorrow at 12. And just by the way, Rob, my neighbor who actually does it, he's like he looks like Santa Claus. Like he's a big guy, he's got a white beard. He looks like Santa. He's actually doing a Santa Claus gig somewhere. So I've actually got to go see Paul at 2 o'clock or so. I got to leave around 1 tomorrow. So I don't want to necessarily turn it off early. So somebody needs to basically take over the Zoom, or I guess are we using Zoom or using Kaltura? So
Um,
anyway,
yeah, we'll stick with the Zoom for now for the Friday live. And Brad, I think Brad's got the agent login as well.
okay. So well, I before I leave, I'll make sure you guys get that. I can't miss Paul in his big Santa Claus debut. So
Yeah.
it's exciting times for all of us. Because growing up, all my kids and their kid friends, every time they'd come over and see Paul, they'd be like, "Oh my God, Santa Claus lives next door to you." So
Magic
it's
time.
it's a yeah magic time. Good time of year to be Paul.
Nice.
All right. So, did you want to show us Kaltura quickly? Are you comfortable with that, or should we?
Sure, it's I can do a quick screen share and I'm gonna drop the link into the chat right now. Now, as the sign up, they're working on a little cleanup here, but with this meeting room, you
Ooh.
have to register in order to get in.
Yeah.
And sometimes the email that you receive back, you've got to reset that in order to get back in. And then you have to use this link to actually navigate to the event room. But I will, for anybody who's not going to go through that process, I will share the screen here. You can see, generally speaking, what it looks like. So it gives us all the tools. There's great tools in here. We can set up a storyboard, customize the background. You can see here we'll have multiple moderators. So Monduit, Matt's up to speed. Anybody else that'd like to help with moderating, Nick Bensa, what have you, just let me know. And then we can promote folks. Oh, there we go. We've already got somebody in. Super. Let me move.
I'm joining too. We'll see here. And
Hi, Kevin.
if I've already signed up with video.agentics.org, I'm assuming it's the same user.
Yes, it ought to be. So here, then we can promote folks from viewers to the stage. And when you're on the stage, I'm going to get an infinite mirror, something like that with the cameras going. You have the regular kind of interaction and group conversations. We can have up to 30 people on the stage at any one time. And then we can create breakout rooms. So if for the hackathon, if there's a specific aspect, technical support, questions around the repo, anything like that, and we want to create a breakout room for that, we can do that down here. Breakouts, we can broadcast to YouTube, what have you. So some of the portions of the hackathon we'll do as a broadcast, like the kickoff, we have TV, the CEO, Patrice, is joining us tomorrow at 12:30. He's the CEO of TV5 Moms USA. So that's wonderful. That'll be a nice kickoff to the event. And then everybody dives in and starts tackling this the challenge. And again, at a high level, the challenge is to find creative ways to leverage agentic engineering to take on the challenge of helping people find content that they like faster. So reduce the amount of time that people spend looking for content. And the challenge is called the Media Gateway. So that should be a lot of fun, and that's going to be Friday, Saturday, and Sunday. We'll keep this event room open up throughout. Probably just leave it up for the 3 days, and folks can come into the various breakout rooms that have registered. So the actual registration form for the hackathon is on the website. I believe is that it's a subfolder, right, Ruv? It's agenics.org/hackathon.
Yeah, it's sorry, you're talking about the npm that I created or the repo?
No, I'm talking about just registering. So folks sign up for the engineers
Oh
consult.
yeah, sorry, it's you're right, it's agentics.org/hackathon.
Right.
I'll slap that in there. I'm having a bit of trouble logging in. I can't log into Kaltura for some reason. Um, hmm, doesn't seem to. So I'll have to figure that out. But
Yeah,
someone
if
else
it,
someone else confirm that the registration works. It doesn't seem to work for me.
I've got
I have the same issue.
right,
Yeah,
and see if it's a reset of the password. I've let
I tried
Zohar
that.
know. Our
I
backup,
tried
so
that
we
as well.
know if we have any issues, will be Discord, and we'll do the well. We've set up the Discord channel, so if we Lynette registered, okay.
Introducing AWS
Yeah,
Security, an AI
it
agent that
definitely doesn't
proactively
seem to work.
secures your applications from
Oh, we're
design
getting.
to
It's
deployment.
Mike.
All right, that was a hot
I
mic.
think I have to create a new account with the same email address.
I tried that. I tried that too. It's so unfortunately, it doesn't work for me. So it may not work for others. It sounds like it doesn't work for a bunch of people.
Yeah.
So we'll need to make sure that someone just Lynette said she just registered. I don't know. Maybe because I'm already registered on video.agentics. Maybe there's a conflict.
Well, I
I
only
don't know.
see two people of having been able to get in, Sharuz and Akena. Thank you, Akena, for giving it a test.
I
We'll
did it
sort it out
yesterday.
with
It took
Zohar.
some time. It's a little bit of yeah, and I didn't get in right away either. I did it yesterday, so
I just want to say that I registered yesterday, so maybe that I don't know, maybe there's a difference from. So I registered yesterday when Rob shared the link. I think, yeah. So
Okay.
And that was just be clear, the Kaltura link. I have no problem registering on the Agentic site. I made that, but that doesn't connect to Kaltura, unfortunately. So you actually have to register twice, which is kind of annoying.
oh,
But
okay, okay.
yeah, so just be clear, we're talking about the Kaltura registration link.
To get into the broadcast room. And again,
Yeah.
we'll share the link again. And if that doesn't get ironed out, then our fallback is to do it on the Discord's one of the Discord live channels, which is already set up.
Yeah.
All right. So I've got Zohar knows, and he's got somebody looking at it.
Okay.
You want to add it to the hackathon page that you need to re-register, or?
That's good.
Well, the good news is we've got the emails. So what we'll probably do and we'll send a message out to you guys or whatever on the final, but I would guess it's going to be one of two places. Either we'll figure out the Kaltura thing and we'll send you some detailed instructions on where you need to register and how, or we'll just do this on Discord. And the Discord we know works. We've done several Discord stages, I think they call it, over the last few weeks, and it works nice. The only thing we don't have with Discord is an easy way to record the video. That's why we really don't use it. The only reason we're using Zoom is I'm recording and broadcasting, and it's just simple and easy. So we would need probably a secondary OBS setup that basically handles the streaming and recording from Discord, which is possible, but I haven't looked at closely. Sounds like a Jed thing to me. But
The master of Discord, yes. Jed, is it okay if I touch in with you a little later on, see what we can get rolling?
Oh, and by the way, guys, here it's that time of year where I get to use this this mug.
Oh yeah.
Yeah, I've got my festive season here. Anyway, totally off topic. All right. So if anyone send me a message if anyone gets in, or we'll share. Do we have a place like a place we can chat? Yes, we do. Now I'm thinking I made it. It's in Discord. There's a Discord chat channel for those who are interested, and I'm going to share that here with you guys here in a sec. And that's probably where we should all hang out for this. So here, let me share my screen quick, and I'll show you guys. All right. So here we've got the media gateway in under the hackathons area. So I'm going to copy this link for you guys. And you can see that we've got other chats going on. We've got a live stage, that kind of thing. So I'm going to pop that into the text area here in Zoom. And there we go.
Zohar just messaged that they're going to have that fixed by end of day. It was a config when they set it up. So
it's
Great.
if anyone can create or find a bug, mostly create them, it's me. that's I should put that on my resume. Creator of infinite bugs. Anyway, you know what goes. I feel for anyone that's building. It's just, the faster you move, the more bugs you create. All right. So in terms of what do you want to cover today? I've got a lot to cover. Is there anything else you want to cover in terms of the hackathon approaches, how we see it coming together, groups?
No, that's all fine. We'll have that all laid out again tomorrow. We've got the Runners show set up. But the other big news is a wonderful event in Tokyo this week. That the Tokyo launch of Tokyo chapter was wonderful. Robert Yee was there. Ken Carter was there. Dr. Chakravorty was there from Sweden, I believe.
Yeah, it was actually, and I stayed up until 1 a.m, and then I couldn't get to sleep. It's, giving a presentation at 1 o'clock in the morning doesn't really lend itself to getting to sleep. So then I was coding until 3.
Yes.
But what was the interesting?
Yeah, I did the same thing. The creative juices were going. I was up until 3 creating, I think, 3 different repos. So
yeah. We gave a nice present. Oh, this is the wrong deck. I get too many decks. Not the right deck. Let me find the right deck. What interesting, we're in like how many cities now? 15, 16 cities?
Yes.
Something like that.
Yeah, that's right.
So Tokyo is just another one. We've got pretty much global coverage at this point. Am I echoing, by the way? Is you hearing an echo? Is that Ben saying?
you're fine.
At least on mine.
Oh yeah, you're definitely echoing.
I'm gonna mute you. Sorry, Ben.
Yeah, I don't know if it's echoing for anyone else, but it's definitely feedbacking for him. I don't know if there's a. It looks like my mic is set up correctly. I can't. I don't know. All right, so let me see if I can find that toke. I don't know.
Don't worry, Ruv. It was my Kaltura.
Ah,
Oh,
right.
okay. No, no
It's
worries.
it's gone.
All right. So one of the things I did this week, well, last week, and you guys saw this last week with the early version of ruvector, was a kind of model that we could use to scale tremendously. Like, how do you handle millions or billions of agents and people and systems all kind of collaborating and updating in real time? And one of the fundamental questions was solving that problem. And I struggle with this idea of doing the homework of the folks doing that are going to participate in the hackathon. So in this scenario, what you're looking at is the ability for a couple things. One, I'm giving you a template to sort of follow. You don't have to follow that. If you're an expert in architecting for 500 million people, by all means, do your own thing. But if you've never done that before, the idea is you can kind of point it at the ruvector repo and explore it and create new creative novel approaches to the solve the problem, at least in the way that I would solve it. And this gives you a kind of running start of sorts. And being that I was focused on that for a while, I got completely carried away, like I always do. I vibed it. I vibe most of this, but once you get good at vibing, you can create pretty much anything, it would appear. And this is the podcast. So one of the more interesting places to look is the examples folder. Now, the examples folder is full of all kinds of crazy. So there's simple stuff like how do you deploy to Google and some tests I did. But there's a folder in particular called the AI 2025. And the EXO AI 2025 is a thought experiment that basically says, what does the evolution of things like ruvector, the graph database, and other structures look like, assuming I continue to build them over the next 25 years? So it's basically saying, what do these technologies evolve into by 2050? And you always get crazy things, but the 2025 part was like, how can I reverse engineer that future with technology that's available to me today? Right. So it came up with a variety of different structures and interesting ideas. In this came, it's got, dreaming systems. So you can see here, it can sort of refactor itself. The dreaming system actually was interesting because the dreaming system became part of the concept of what later became ruvllm, which allows it to sort of work on the information as it's sort of processing it. People are interacting with it, but it's not necessarily taking everything it's learned in real time and applying it. So the dream set sequence allows the system daily or on some sort of ongoing basis to basically reevaluate what's happened as it's interacted with the various users of the system and essentially reprogram itself, redefine its logic, redefine its learning, redefine how it reasons about things in a kind of dreamlike simulated state. It literally creates simulations of what it's learned during a day and then figures out how to optimize for those simulations, running multiple versions of itself, which is just out there. And the fact is, no matter what the Reddit friends say, it works. It totally works. So you can dig into these. So you can see there's multiple files here. There's different systems you can go into. And if you really want to go into crazy land, there's I haven't pushed it yet. I probably have to push that. I'll push that later. There's a research component. Actually, if you go into my various actual branches, let's see if we can find the crazy land one. Explore low latency simulation. That might be it. I gotta remember. I can't remember where I think it's a low latency simulation. This was inspired a little bit by Kobe. Um, so we'll go in here and we'll go into the doc, and you can see here based on different folders when it was updated 4 hours ago. That's what you're looking for. So some of the most interesting things aren't even in the main branch. This is one of them. So we can go into this branch. You can go back into, I think it's XO 2027. We go to research, yeah, and then we find even more crazy. So basically, taking all these various ideas, then I realized that you could do interesting things with like neuromorphic spiking networks, which basically takes this kind of zap approach to AI, where it rather than sort of igniting the entire neural network like you do with traditional sort of LLMs and monolithic models, what this does is basically uses a kind of spike to just activate the particular parts of the model that need to be activated in much the same way your brain only activates a certain neuron to do a certain thing. So it applies that concept on top of all the other things we've done. And yeah, so you can see that this is implemented and I'm working through that. We can get benchmarks. Some of these are further along. It's created things like a time crystal, like this is stuff is just, I can't even explain half the things, but basically what the system is doing is learning how to sort of optimize and build and do these things, and it's using these really low latency sort of loops to do that. So that led to this idea of doing ruvllm. Now ruvllm is particularly interesting. So I've combined all the things that I've shown you guys in the previous weeks, the idea of graphs, the idea of vector space, the idea of self-learning attention mechanisms, and this essentially, and I don't want to describe it this way because I think it scares people, but it's essentially a virus that takes over the LLM. And once it's injected itself into the LLM, I saw this documentary the other day about these slugs. I think it was a slug that basically get taken over by a parasite, and then it rewires their brain, and then they start doing all these crazy things. So they attract birds, and then the parasite gets into the bird. And essentially what this parasite is doing is rewiring the synapse and neural structure of the slug to basically take it over and make it do things. In essence, I saw that on, I don't know, it was Netflix or some show. And I'm like, we could do that for an LLM. Now there's two sides of this. So you can use this idea to sort of rewire the weights and the parameters within the LLM instantaneously. Now, here's the weird part about this, because I'm using a LoRa. The LoRa is a low, it stands, whatever it stands for, I'm drawing. So I'm using a micro LoRa architecture, which basically allows us to sort of quickly and easily rewire the workings of the model itself. Now, hypothetically, I'm using this to make it smarter and more capable, and I'll show you some stats here in a minute. Substantially more capable for smaller models, like a 500 million parameter model to maybe a 2 billion parameter model seem to work the best. You're making dumb, light, fast models actually smart in very particular, narrowly focused areas. So if you need that model to be the best capable model ever for legal, but dumb for everything else, this is perfect, right? Because you can inject it with that information. Now, inversely, back to the virus idea, hypothetically, you could use that to rework the LLM for all kinds of nefarious purposes. You could make it uncensored literally in a moment. So potential vulnerabilities are also big. This would be, I would say, I don't want to go down this road because it sounds way too negative and I don't want to be particularly associated with it, but it might be the first true adaptive LLM virus created, but it's created for the purposes of benefit, not for the purposes of exploitation. Just to be clear, don't do dumb shit with it. But that said, all kinds of potential opportunities to use it. So in terms of the last part, I needed, because I'm basing this on the concepts of kind of the other end of the spectrum. No GPUs. I want these to run inside Claude Code instances. I want these to run in CPU environments. And by the way, Claude Code environments are amazing. I've seen you get a variety of them. Some are more than others. I think they're in some cloud environment. But on average, I'm getting 32 gig RAM. I'm getting full ATX 5, which is like high-end Intel processors. The infrastructure is amazing. So once I realized that, I could start federating and using the sandboxes. I created a federated component. Now for the federation, I actually end up using E2B. E2B also gives me really beefy sort of sandboxes I can work with. So I then was able to spin up thousands of these tiny little agents that were using the combination of all the things I was just telling you about, the graphs and the LLMs and whatnot. And then that could federate the system and train the system on different tasks that I needed it to do. So one of the tasks was for one of my clients, and we were doing a simulation of their business. And basically, what I'm doing is, and this is a lot of work of of an agentics engineer, is I'm basically trying to figure out, one, what does that business do today? How does it operate? How does it interact with its customers, its employees, its suppliers, and all these various things? So essentially what I did is I took all these things and I pointed it at their database, which is they predominantly use like an Airtable, and their Google Drive where they keep all their documents, and a variety of other sort of secondary like CRM type systems. And then I basically said, create a detailed simulation of exactly how this business has operated over the last 12 months. And this isn't simulation. This is essentially taking all the things that they've done as a business for the last 12 months, exactly how they do it, including the life cycle of the customers. I looked at their emails between the people sending back and forth between their lawyers and whatnot. And eventually I created a very high resolution version of that what's actually happened over 12 months. At which point I told it to learn. I told it to, now that you understand the basis, look at opportunities to automate portions of that business. And we found lots. Most businesses can be automated quite readily using this approach. Then I simulated the next 24 months. To do that, I did thousands and thousands of simulated sort of versions, black swan events that would say, something bad happens, there's a tornado or whatever. All these various sort of simulations, and I looked at what potentially could sort of emerge from that. And what I ended up seeing were some really interesting statistics. And oops, I'm going to share my right. I went to my wrong screen. One sec, guys. All right, here we go. All right, so I ran this, and it's just running. You can see it running down here currently. But basically, I'm running a simulation of the business. So what this looks at is the sort of the technologies. And I think Jed was asking about this earlier, like how am I doing the actual language model itself? Well, in this case, this is using the Qwen 2.5 0.5 instruct model, which was the lightest, and I could embed that model directly in the sort of ephemeral agents without a lot of overhead. And in this case, I'm using the 256-bit vector AVX2. Now, I could use AVX5 if I got better servers, but to be honest, it was good enough. And what was interesting is I started optimizing based on different baseline parameters. So the baseline parameter was like, how much money are they currently making? Sorry, guys, I'm probably sharing a little too much, but you get the idea. And then how much can we enhance that through, automation and simulation, and basically give you a kind of guidebook to how to sort of take that and make that better. And what I saw was, I was starting to see this, really a sort of self-improvement loop. And when you look deeper into like the operations, like it gives you a complete operational guide. Here's what you need to do. Here's how you are going to do it. The systems actually started working really well. And I saw sort of this idea of a gross improvement in things like settlement, right? So by substantial amount. So we're going from 66% settlements to 96 hypothetically. We got to put this in the wild, but likely substantial improvements. And this is using that combination of self-learning and sort of a broad federated network of agents that are going and researching and operating as different parts of the business. So each agent represents an employee or a supplier, a customer, a regulator, the whole kind of constellation of things that make up the structure of a given business. It replicates all of that. So I could literally point this and say, give me a representation of Google, show me every employee, show me every billion users of that system, and simulate that thousands of times, every hour, forever. And what that opens up is insight, right? It gives you high fidelity simulations that are grounded in real information flowing from the internet, real information flowing from the company, and all the things relating to it. And previously, to do that kind of simulation, you could do that obviously with GPUs, but you would be able to get that level of granularity was really difficult with a GPU based approach, because you're using sort of this average approach, right? You're doing this kind of give me a million possibilities and give me a million answers to that and give me the sort of best result from that. But what you're not doing is granular simulations within the structure of that simulation, a kind of meta simulation of a simulation. So each agent now is actually doing the job, doing the task, doing the role, doing the part of the assembly line, the supply chain, whatever it needs to do. It's actually doing those parts and separating those into millions or billions of different sub processes that run for a moment, long enough to do whatever they need to do, then go away. And then that's being fed back into the graph. That's being fed back into an LLM, and it's learning from those things over and over and over again until it gets the sort of fidelity output that says, we can do, in this case, 227,000, outcomes a second. I can do financial calculations, at 8x factor. I can do strategy scoring, using multiple variants. So I'm doing all this really, really deep sort of understanding in real time. And now the $1 million, $1 billion question, and I don't have the answer to that yet, is what does it look like when I go from this kind of high resolution simulation to a real functioning agentic company that's now operating in tandem with people, customers, and agents doing some of the work, right? But the cool part of this entire thing is that migration from fake to real, simulated to actual, is now only the question of data. It's now, rather than pointing it at that sort of historical data set that I was using to sort of model it on, now I'm just using the real live system with real payments and real customer emails coming in and real things. But the structure semantically is exactly the same. And seeing the difference between simulated and real is a just an evolution from one to the next without any real operational changes in what I've built. That's what all this stuff is doing, right? So I've got all these tools that allow for me to do the real-time embeddings. I created another tool here just because I wanted to, that allows me to do, here's the Onyx embeddings. If you want to use Onyx from, like, you can integrate that. We've got, what else do I got here? I guess so much stuff it's even hard to keep track of. I got, the crates is also another interesting place to explore. I got a Postgres version. All right, I'll go in. We can build some stuff here in a minute. I just want to give you guys a quick update on some of the stuff. So everyone's like, well, I don't need another a database. I use Postgres. I'm like, all right, how hard could it be to do a drop-in replacement per PG vector in Postgres? Now, so I took this a step further. Not only did I do a drop-in replacement for PG vector with exactly the same fidelity and capability, but better, I then packaged this whole thing up and created its own Postgres distribution that includes all the other stuff that I've shown you directly integrated into the core of Postgres. So back to this idea of a virus. Now this virus is infecting Postgres. It's now put its tentacles into all the internal operating parts of Postgres and understands from a structural point of view how these things work. So I've got, core vector operations. Let's see here. Let's see if I can find some better stuff. Here we go. So we've got the learning module implementation. So I've got various types of learning built directly into Postgres. I've got the ability to do various types of additional reasoning and all the other things that you've seen, and you can call these as Postgres functions directly in your SQL. So I've infused this idea of adaptive intelligence directly into the structure of your Postgres database. So if you're using, like, a Supabase locally anyway, you could just pop this thing in there and suddenly make it smart. So you can see I have different algorithms. I've got different concurrency mechanisms. I've actually improved the performance tremendously of the vector, over what PG vector can even do. You can see here we got a graph library. The graph library essentially allows you to do all the graph related work. So you get native Neo4j directly in Postgres. No secondary Neo4j installed with their stupid JVMs. You can get all the benefit of a Neo4j graph environment without even installing Neo4j. I've got 100% fidelity to their Cypher API. You can take things further. You can do traversal, things like dexterous shortest path algorithms. You can just do all kinds of stuff. So what this is cool is back to the original idea. So I'm taking I'm looking at companies' data, right? And then I'm inferring how they operate and how they can better, operate within the structure of their existing organization, employees, whatever. Now what I can do is I can take a dump of all their data. And I don't even care what as long as it can be imported in the Postgres, which is generally just a CSV or a SQL. And I can then basically infuse everything I was showing around simulations and learning directly into the data structure itself, understanding how they operate, seeing unknown paths between different data points, and that just kind of magically works. So you can grab some of this, and I'm kind of staggering the stuff I'm publishing because I just got so much stuff, and I don't want to just post it every day. But if you go to npm, I think I gotta remember what I called it. Was it ruvector Postgres? I should probably ruv. Uh, I think it was post. Yeah, here it is, Postgres CLI. So yeah, this is something I published apparently a day ago. And so if you're interested, there's two ways to use this. I basically kind of made it similar to like how you install Supabase. So if you ever installed Supabase, I've made a similar sort of installation. The easiest is probably use a Docker type instance, and you'll see that in here. Where's my Docker? Yeah, there's a Docker file. That's the easiest install. Go with the Docker and it'll just set it up in a Docker instance and you can fool around with it. But this entire database actually works within Claude Code Web as well. So if you want to go to Claude Code Web and basically say, I don't know what the heck he's built here, but you tell me about it. All you need to do is go here, grab this line and type something like, what kind of crazy did Ruve create this week with that? I'm going to cheap out on the model here. Let's go Sonnet, and we'll add to the Vibecast. That's it. That's all we need to do. And fingers crossed, I didn't break it, but it should install. Now you've got a full intelligent Postgres database directly in Claude Code Web. And you can import files, you can update things, you can point it at different databases, you can integrate APIs, and you can just play with it right here. You can then export your SQL or your model, whatever it is you want to do, and you're good to go. Yeah, you can see here that I'm doing benchmarks. So I have a tendency to use Claude Code Web as the kind of customer or end user facing part of whatever I'm building. So let's take a look at Agentic Flow 2.0. All right. So I'm working on Agentic 2.0 bug status. I got a few bugs, converts in the wrong direction. I think I fixed this last night. But basically, what I'm doing here is I'm preparing for the next major release of Agentic Flow. I've already published the alpha for AgentDB, but basically, AgentDB is the sort of is the learning system and the vector. So that AgentDB's the V2 alpha has been upgraded to ruvector. That forms the basis of the sort of intelligent layer for agentic flow. Agentic flow allows you to deploy agents sort of independently of Claude Flow using Claude Flow style or Claude Code style MD files and skills and commands and things like that. And so I've infused all these things into sort of a package. Once I've got this all built, Claude Flow V3 will come out. V3 is going to be just off the hook, off the wall, out in left field. What that allows to do is take all the stuff I'm showing you, and you're going to be able to run it directly in Claude Code with native sort of support, and it'll has a migration. So if you've been running Claude Flow for the last couple months in a repo, it'll just take all the stuff you've already done, and it'll improve it by using the migration script and update it, and suddenly you'll be using all these attention mechanisms. You'll have, GNNs, graph, and you see here I'm testing the different performances and my throughputs. So I'm getting just spectacular results here, and this is how I'm doing it. Now, if you're curious, we can see here that there's the branch name, and I'm in Vibecast, and a lot of my experiments are in Vibecast, and that's where if you're always curious to what I'm up to, you can go to my branches. So in this case, you can see lots of different branches, and we're going to take a look at this one. And I like this. It's just kind of a simple little branch. We can see. Well, this is basically a benchmarking one I'm doing. So was there any docs? I gotta probably create a doc. I don't think I've created a doc here, so not too much to see here. So let's look at another one. Here's the Postgres one. Let's take a look at if there's more details here. Postgres deep review. This is what I just started. So this was created, oh, this is yesterday. So what this is doing is basically, this is proving to me that it'll install in environments other than my own. Now, I use Docker often for that. And also the GitHub Actions and workflow allow me to simulate Macs and Windows and things like that. So I'll use those as well. But generally, the first step after I do a release is I go and just check that everything works. So this is telling me that my runtimes, my various settings are working. Whether I've got 2,500 tests in this. I've just gone, my test-driven development is just nuts at this point. And that's what happens when you spawn 50,000 agents to do things, I guess. Documentation. And by the way, I've gotten really good at creating really, really large swarms of agents that can just go out there and build, well, in this case, a completely new novel graph system, a completely new novel vector system, and a complete distribution of Postgres. So, and amongst all the other crazy things I've been working on this week. So we can see here that we can see the core vector types. I've got more vector types than PG vector, and they're faster. I did the distance calculations on different types of functions, so distance and cosine, things like that. You want these for different types of structures. So the structure of a swarm might be a little bit different than a structure of a legal document. And the system will figure that out if you ask the right questions. You'll see that I did include the AVX 512. So if you're running a decently new high-end Intel processor, you don't need any GPU. And I got to give it to the folks at Intel in particular. Their non-GPU AI stuff is top-notch, really good. And I don't know why they're not getting more, like cred. Everyone likes to shit on Intel right now. But if you're looking at the end of the spectrum where we or me plays in sort of anti-GPU style AI, their AVX and related tech is awesome. Like I'm getting way better performance from their CPU than I am getting from low-end GPUs. So for bang for your buck, yeah, the I think it's i7 and above that includes some of these optimizations. You're definitely looking pretty good. Now, the other thing I've included a few other, this is a lot of technical jargon, but you can see here I've got my intention layers, my routing, learning, graph, and hyperbolic. Hyperbolic, I think, is the hyperbolic learning system that I've devised. I'm fairly certain no one else has ever done. So someone other than me will have to confirm that, and but I can't find anyone doing anything like it. No one's applied it in that way. I won't even start to try to explain it. It's vector space AI. All right, so we got benchmarks. We can see here my benchmarks, nanoseconds, right? Look at it. So this is what I'm talking about Intel for a moment. So AVX2 is standard, pretty much any Intel and Mac. So most processors basically support it. Jed will probably explain it better than me what exactly it's doing, some kind of matrix math. But basically, I'm seeing ridiculous timeframes on some of these calculations, like 38 nanoseconds for a lookup on a 1536 is already bonkers. Now I've taken that and made it even faster. So this is the heart of the sort of value proposition of these systems that I'm building. Inside, so we go back to this idea that I'm creating simulations, right? I'm saying I'm creating meta simulations of simulations within simulations, and then I'm doing that really, really quickly, billions and billions of times a second, potentially. If you look at some of these models, we're doing them, quadrillion times because it's a meta simulation. The system is able to simulate multiple potential pathways at the same time because it's essentially a kind of holographic echo of the simulation. So you're not bound by the limits of the CPU, which would never allow you to do quadrillions of calculations because the CPU is bound based on the maximum amount of clock cycles, right? So traditionally people would say, I'm going to base the core of my simulation on the most I can get out of the CPU, which would be like if it does a billion or whatever calculations a second. That's the most you could possibly get. But by doing this kind of meta simulation or this kind of meta reflection of the simulation, you're able to just sort of do multiple simulations of the same simulation on the same hook or the same loop, if you will. That's what this is showing. So when you get low enough, that's back to this idea of the causal effect where the what's happened, what's happening, and what will happen blend. It's this weird, strange loop concept, but it's based on really, really fast, tiny little agents, essentially, that do just one little thing as part of a broader group of things and are capable of collaborating with all the other agents doing those other things in a super high speed fashion. So when you think of in most simple terms, when you think of like the agents that I'm showing you doing multiple sequential things, right, in Claude Code or Claude Flow or whatever your preferred environment is, that's taking a really long time, right? You're doing your 1, 2, 3, 4, 5, 6, 7, and that could take, hours to run. So separate those into really small parts. If you can take that thing that just ran, for an hour and separate it into a trillion or quadrillion small little tiny little pieces, that's where you start getting these kind of opportunities. And all the while, each one of those tiny little things is now basically educating, learning, improving either the graph, the vector, or as of this morning, an LLM. Let me pause for a moment. Am I blabbing in crazy land, or does this make a little bit of sense? I know I know this is a little bit out there. All
I
right,
guess the
just
big
jump back.
question on everyone's mind room is, how do I make it work for me?
Well, look, this is like for those who are not crazy mad scientists, and I admit I've gone into crazy mad scientist a little bit over the last couple of weeks. But what kind of crazy did Ruve create this week with this thing, right? That's literally all I asked, right? And please install it. Let's see what it told us. So, and this is just a blank starting point, right? No, says so. Ruve's cooked up this week. The TLDR, a PG vector replacement on steroids. I don't know if we should use steroids. Steroids are bad. I'm not Lance Armstrong. Is that steroid guy? Anyway, ruvector is a Postgres vector extension that makes PG vector look like it's running on a potato. Okay. Core features 7.4 times faster, so that's 740% faster than PG vector on distance calculations, 38 nanoseconds versus 280 nanoseconds. So remember, you can see it was testing the system earlier. Now, I've included the Tiny Dancer AI routing algorithm. So the Tiny Dancer, and in fairness, Elton John came on when I was working on this, and that's how it got the name Tiny Dancer, but it's actually a cool little thing that I've devised. It essentially allows it to auto optimize the AI routing. So back to the original simulation idea. Sometimes you don't want to route to Opus, it's too expensive. I applied a fast GRNN directly to the routing. So basically, there's an attention mechanism applied directly to how it routes to different LLMs and different. So it kind of figures out where and what it needs to do without me specifically telling it. And that's infused directly into Postgres in this case. Full attention mechanisms, flash, multi-headed attention, and sparse attention. So multiple attention mechanisms that grow within your data. Graph neural networks for those that want. So I support GCN and GraphSage and basically Neo4j. And hyperbolic embeddings. So this hyperbolic embeddings thing, I don't fully quite understand. What WTF? There we go. We'll see what it says about what the hell that is. So it's about 2,200 lines of Rust code. I'm going to tell you something, and I've said this recently a lot. It's not, and I was guilty of this for a while. It's not the lines of code that matter. Like the fact that I can create 20 million lines of code is actually a bad thing. The key is doing this in the least amount of code. The bragging rights is I did all this with 22,000 lines of code, not that I did this with 250,000 or 2 million lines of code, right? So ultimately what I'm trying to do is not say, if I can brag about anything that, the amount of lines of code that I've been making over the last month is at a 12-month low. That's the bragging rights here. I'm doing more with less. And ultimately, when you're looking at these applications, the least amount of code means less bugs, less problems, less crap, more reusability, more modularity. And that's a direct correlation to the modular approach that I've been showing you guys, the ability to plug and play these various parts. So when you go back to ruvector for a sec and look at my sort of collection of stuff, ruvector, here it is. You'll see that everything, and I don't even include everything, but everything you see in here is a kind of pick and play approach. You can say, well, I only need the graph. Okay, just use the graph module. I only need the attention, or I need to replicate, or I need to do a cluster, federation, or I want the tiny dancer. And then you can also do that, and here's the Postgres stuff I added. If you're, and if or for example, in the Ruv LLM system, actually one of the most capable parts of the Ruv LLM system is actually something that I've called SONA, the self-optimizing neural network. So what the self-optimizing neural network does in the context of Ruv LLM is it provides the ability, the core ability for it to learn. So I've separated each of those parts. And so now you can take this and say, well, I actually want to do it as part of a distributed GPU. Now, I don't have a GPU farm at my disposal, but if I did, imagine what this would do for large scale training. Like I could apply this directly in the large scale GPU training cluster and have a combination of real time learning, optimization, and adaptation as part of that. Now, when you think a little bit about like DeepSeek did when they're claiming $4.5 million spend on their on training DeepSeek V1, imagine what this would have done for that. We're probably going from 4.5 million to, I don't know, how much does it cost to run 100 H100s for an hour? And that's probably a question for Jed because I think you've got the that sort of infrastructure set up. That's
70
where $70. So
$70 for 100 H100s on a Rackspace spot.
that's what we need to do next.
So I think would probably be on the order of $300 an hour.
Yep.
Just to give you a sense of the scale of on demand versus spot.
So we should do that. Like, what the heck is so to do that, maybe we should just do that now. I don't know. But what we would do likely is we would set up, we could probably go in the Claude Code web and put in the API key for Rackspace Spot instances and point it at this particular my repo, probably the Sona. If you want to use this directly, you can actually go and I think, did I do this as a npm? I may not have done this one as an npm, but there's, oh yeah, there is. Here it is. Pointed at this npm, you're going to get slightly better performance from the Rust core, but I'm actually compiling these all for, let's look at the code here and see what I compiled it for quickly. All right. Yeah, here, so I compiled. Do you see the compilations here? I've got Windows. Yes, I got Windows because I know Timu made me do it. I've got ARM. I've got Linux. I've got Mac. So yeah, you've got all the. As long as you're using one of those architectures, and again, if you're using Rackspace, I'm assuming it's probably Linux anyway. But even if you want to set up your own cluster on your Mac, you can just go and do that as well. You can train it and it's already optimized for SIMD and all the AXV5 and all that other garbage I was telling you guys about is ready to go. I think I don't have any proof, but I'd like to have some proof other than me blabbing on a Thursday that with this architecture we can make a significant improvement in like monolithic LLM training. And I'm talking like like $70 from $4 million to $70 kind of stuff. So to prove that, what we need to do is basically sort of show like how I think DeepSeek went from using I think they based theirs on Gwen, if I'm not mistaken, and how they went from like the previous iteration of Gwen to DeepSeek, and how we can do the exact same thing at a fraction of the cost, with the same basic output. Once we've proven that, then we can go again and we can crank it up a notch and train the best reasoning model potentially that exists. Needs to be proven. I haven't gotten there yet. Yeah, so check out that if you're interested in that line of thinking. Where I gotta find where I put the chat here. I'll pop that in there for you guys. There you
Ru-
go.
is ruvector the repo we use to simulate a business?
Yeah, so there's another simulator I've called it. I call this agentic synth. I told you guys I'm on an epic roll here. I've created hundreds of things in the last 2 weeks. Actually, in the last month, I'm all kinds of crazy. So what this does is creates the synthetic data. So what this essentially allows us to do is fake API and streaming content data, right? So think of like the output of like a brain chip or a industrial control system or stock trading or a Bloomberg terminal or an API you don't even have access to, right? So let's say you want to build for a platform and they charge a lot of money for you to use that API. Now, oftentimes, most people will actually give you the specification for the API, but they may not give you access to the API. What this does is allows you to completely fake that interaction and ground it based on like Google, real information from the internet, different data sources, and then create a sort of stream or a structure like files, MD files, PDFs, whatever, that represent that data for whatever purpose you're looking to represent. I could literally simulate a nuclear power plant's internal operations with this, right? So it's simulating all that information, streaming it, and then as it streams to me, I'm able to do the introspection of the streaming and then train the system to get better based on the things that simulation is doing. Better optimizing the nuclear power plant, better optimizing the sensor within the nuclear power plant that does that one little thing, simulating all parts of the nuclear power plant to do various parts better. So
Do
in
you
this
also
case,
combine this with existing data? And if the
mhm.
power plant exists, so how closely aligned do you need the simulation to be to the actual business? For example, a law firm, you can get clear indications on win-loss on the cases, but like a pizza factory where the guy could be making 8 pizzas, but he's a guy that tosses up the dough and he's losing 3 pizzas in time because he entertains. It's not
Yeah.
a complete one-on-one match. How closely do you want or need to be in the
Well,
same?
let's
Yeah.
well, the higher the more realistic the data, the higher the fidelity. So when you point this at an existing business that has operations and databases and HR systems, high fidelity, right? I can use that to get exactly the simulation of what's happened over the time that I have the data available to me. So if I get a business that's 20 years old, I could simulate the entire 20 years of that business based on that 20 years, I can see the evolution, the progress, the problems, the challenges, and optimize for two things. I can say, where can I put agents into the mix, which is pretty much everybody, right? It's like, and straight up 10% of any business easily can be replaced with agents, 100% replaced using this approach. It finds those inefficiencies and the things that just people aren't doing well, and it'll replace those. That right there is generally speaking the profit margin or a significant improvement to the profit margin because those are jobs. I know I sound terrible saying it. I'm only going to deliver it unfiltered here. Those are the biggest expense in a business is HR, most part, unless maybe you're in manufacturing or something. But for the most part, most modern businesses, the most expensive and cost, the part that kills you and makes you profitable or not profitable are people. That's why tech
Human re-
companies lay off thousands every day, and it's just a quick way to make profit.
human resources. Yeah.
Human resources are the most expensive part of any business. This can model that really easily and then simulate it and then go from simulation to real by just asking a few of the right questions at any given point. Now, if I don't have that, let's say I'm a startup and I want to simulate what my likely path to success is over the next 2 years, then I'm going to go in here and say using npm ruvector, npm agentic flow, and npm agentic synth, create a high fidelity, I gotta spell it right, fidelity simulation of a next generation nuclear power plant management system, including all supply chain, human resources, industrial control systems, and related business requirements as a requirements. Use the E2B API key and spawn 500 agent simulation federated simulation and save the results in slash reports. I'm going to actually start lower just to test it. I'm going to do 5, and then I'm going to span it up to but before I get to 500, I probably should optimize it a little bit. So I'm gonna do that, create results in that, and also explore. You know what? I'm gonna give this the full meal deal. I'm gonna go here, and I'm going to spell fidelity right, and use RPM at ruvector / ruvllm. Why not? It's part of it. And I'm going to tell it to use SIMD. That'll optimize it further. And it works. All right, that's it. That's exactly. And I'm going to use a relatively shitty model for that. Not that Sonic Platform if I'm bad, but it saves my credits. I'm going to give it my full network knowing B. I'm going to give it my Ruv environmental variables. I'm going to create this in the Vibecast, and I'm going to also tell it to save frequent commits to GitHub, spawn concurrent tasks, speed up the development. This is totally vibing. All right, we're gonna do that. All right, so that's it. So I'm gonna pop that. I'm gonna give you that my rather crudely typed prompt. You guys can try it as well if you want. You just replace nuclear power with some other business. And you remember, you're gonna have to sign up for an E2B key. The E2B gives the system the ability to spawn multiple agents that work in parallel to this sort of central orchestrator. So that's how I can do 500 or 50,000 agents. Be careful using your Anthropic key here. I mistakenly spent a couple $1,000 last month on Anthropic because I included my Anthropic API key, and it went and used it, and it did some crazy stuff. I don't mind the money, but just be careful or set limits on your API key. Let's jump back to this for a sec. So we had asked a question earlier. What WTF? We have, what is this thing is basically what I'm asking. And so it says normal vector embeddings like OpenAI's Ada O2 live in Euclidean space. Euclid, and I think I'm pronouncing that right. Flat, boring, high school geometry. Works fine for cat is like dog, but breaks down for hierarchies, which is kind of what I was saying. Hyperbolic embeddings use negatively curved space, like a saddle or Pringle chip. This unlocks something mind-blowing. My mind's already blown just in that, analogy for like a Pringle chip. Why it matters. In Euclidean space, if you try to embed a tree like an org chart or a knowledge graph, you need exponentially more dimensions. A tree with 1,000 nodes might need 500 plus dimensions to avoid squishing the hierarchy. Well, I like the squishing hierarchy. The hyperbolic space, the same tree fits in 2 or 3 dimensions with 0 distortion. So the magic math, hyperbolic space volume grows in some kind of weird calculus. Euclidean space grows as some other kind of weird, math I can't quite articulate. Translation, hyperbolic space has exponentially more room as you move away from the center. So think about that for a moment. I'm literally creating a multiverse in a hyperbolic space. It's literally, if you think of the multiverse as multiple universes I'm generating multiple universes using the same structure and then applying the information in between, the sort of foam that exists between each of these universes. If you believe in multiverse, this would literally be how you create the multiverse. Then I'm applying this kind of multiverse structure using a vector and graph representation of it and applying an attention mechanism between the two. So it learns based on both where it exists in the multiverse and the physical reality exists within the application of that as a graph. Yeah. So why this is bonkers? I didn't say it was bonkers, but most databases here's your vector cosine similarity. Ruvector lets you map your embeddings to a point care disk using Lorentzian inner products and compute. I can't even say these words in a negatively curved space-time. It's differential geometry and Riemann manifolds to do database queries. Like what? Has anyone else done this? I don't even know. But the craziest part of this, all this bonkers whatever, is it actually works really, really, really fast just to do the simulations. So it's generating, I guess, what some would call a world model, literally, a multiverse world model that represents its reality and then simulating all the parts of reality, kind of like people in our reality, and then attempting to find the optimal path to the optimal solution to that simulation. And it's doing it in like seconds, which is what we're doing over here. Let's see how this is coming along. All right, so I'll be create a high fidelity nuclear power plant management simulation with federated agents. Let me break down this into tasks. All right, so it's creating the tasks. It's doing whatever it's doing. It's creating some simulations. Remember, I'm creating the glue. I've already created a lot of these sort of core capabilities by doing these imports. So it doesn't need to do all these things. It just needs to sort of feed all these things in. So in this case, you can see it doing the control flows, the neuron flux, which might be my new favorite thing today, and fuel burnout and other things. I don't know anything about nuclear power plants, so I'm going to have to assume it knows what it's doing. And now we've got supply chain logistics. So these are spare parts, chemicals, waste storage, industry, whatever's. Okay, looks good. Let's keep going. This is the workforce. Shifts, training programs. Here's different radiation safety, security protocols. So hypothetically, let's say a nuclear power plant hired me or one of us to do the work. This is what we would do. We would point this at their existing data, their existing training materials, their existing operations, any problems they've had, whatever that takes you to manage and build that business. And you're going to literally just point this thing at it and say, how can I make it better? We keep going here. What else we got here? This is the business operations. So these are operating revenue, cost, profit, cash reserves, electricity prices. Now, which is cool about this is, let's say we're looking to compete against a customer, or how am I going to compete against my biggest customer? Well, I can literally simulate their entire business. I can figure out where their business is inefficient, and then I can ask the system of how can I don't want to say anything bad. Okay, well, how can I destroy my customer, or not customer, my competitor? How can I beat them in every way possible? How can I outmaneuver them? How can I run this business more efficiently and more effectively than they do by simulating every part of their business, right? Which is pretty cool. All right, let's keep going here. What else we got? Now it's creating a federated agent. The federated agent is interesting. So what the federated agent does, back to the E2B instances, remember I said I was going to do like 500 agents? I could do millions of this, right? Depending on the size and scale of the system I need to federate. I might do, let's say there's a large company and they've got 200,000 employees. I might want to do, because I'm using a simulation of a simulation, I don't need to simulate every single user. I just need to simulate the right people within the organization, the key inflection points. But I have to feel like it could and simulate every single one. But basically what I'm doing is saying I can spin up a few hundred agents and they're doing basically simulations within that structure of what they're doing on a daily basis, emails, code, whatever, and looking for inefficiencies in their business. So in this case, this is looking at analyzing nuclear reactor data. So remember, it's creating simulation. This is how the simulated data is being generated, right? So it's basically generating it's asking, in this case, I think I might be using, it looks like I was using Sonnet 3 or something, but it's basically, it's asking Sonnet to create a stream of information that looks like the real thing, and then using that to simulate it. Now, again, I don't have to use Sonnet or anything. I could literally train my own model to do that. And one of the more likely scenarios for me to do this going forward is what I was doing with that legal example earlier. I was training a really light model to really understand just the particular nuances of that particular business. It's really, really smart at that business, but can't do really, then it's just a dumb, low weight model beyond that really smart, intelligent part of the model that I trained. It's like I trained it to play guitar, but if you give it a tuba, it's dumb, right? Does that one thing really, really, really well. And I can train it to do that one thing really well in a tiny little language model. So it knows and can then, as the thing operates, it gets better and better. And the language model becomes the voice of the crazy that sits behind it. Without the language model, I'm just getting a bunch of like really interesting data, but I'm not able to understand the data, right? So the language model gives it that thing that we have as humans that goes from idea to, the articulation of that idea. I'm giving it an ability to articulate its conscious construct. It's a reasoning, it's self-awareness. It gives me a mechanism to interact with it in a way that's meaningful to me, who interacts through voice and text and language. All right, so we got that. We got simulation, orchestration. You can see it building all the stuff. This stuff is being built concurrently. Vibecast. All
Ruby, you
right.
going to show how the LLM jumps on the front of this?
Yeah, I've added the LLM in this as well, so it's working through it. Excellent first commit push. So let's go back to the Vibecast. Vibecast branches, and we should see a nuclear power plant. And here we go, a nuclear power plant simulation. We've got I don't think there's there's not a lot of documentation because I vibed it, but we can see the parts. You can see the business operations, the HR, the ICS, the supply chain. Yeah, that's looking pretty good. Now the next step here, it looks like it's creating see what I did, and this is an important distinction, especially if you're using things like Claude Code Web, is to tell it to frequently update the GitHub. Then then you can kind of see what it's doing. And the problem with Claude Code Web is it kind of obfuscates a lot of what it's doing in this kind of weird UI. So by frequently updating the actual GitHub, I can see what's happening more efficiently rather than having to kind of show difference here, which is what I'm doing. So this is the nuclear power simulation documentation. It's nuclear power plant that simulates high fidelity system that models and whatever, agents, simulation, reporting system, key parameters. Yeah, creating a high fidelity nuclear power simulation system for fun, on a random Thursday. So here are the agents. Here's the JavaScript you need to interact with it. Supply chain states. This tells you how to use it. Let's give it a go. Deploy this system using the E, E, E2B API key in the sandbox secrets. We'll let that go do its thing. Let's take a look what did this say? Oh yeah. Has anyone else remember all that craziness I was telling you about hyperbolic embeddings? Short answer, not really in production databases. So at this point, we are first in so many things. It's almost like it's doesn't even matter. It's back to the Reddit guys that say I'm just vibe coding a hot pile of garbage. But you guys try it. It seems to work. Hyperbolic embeddings are hot in the research, but basically non-existent in production vector databases. Point care embeddings, original work 2017. Of course, it's Facebook. Facebook's lost our favorite non-LLM believer. Lorenz models 2018, better pneumatic stability, but Facebook implementation is PyTorch, not a database. Genesis and PyLibrary, come on, enough of the Python. And so it's all academic. PG vector standard Euclidean only. I've got numerous different types of vectors, like a dozen different vector styles. So I'm way ahead there. No hyperbolic support found in docs. Other databases, Pinecone, Weaviate, Q, all use HNSW with Euclidean metrics only. None found with production hyperbolic support. There's a January paper arguing that hyperbolic embedding should be standard for health knowledge graphs, which is exactly what I've been saying. So back to it exists. Let's just go back here and try to get the simple explanation again. The hyperbolic space has exponentially more room as you move farther from the center. It's the universe model. It's the expansion of the universe, right? It literally is the expansion of the universe as defined in higher dimensional space. Why is that important? Think of a genome. Now think of the ability to cross-correlate your personal, programming, your genome, your DNA and your RNA in a way that is meaningful, that can be navigated almost instantaneously and correlated to things like the bacteria in your gut, right? That right now is hugely costly. Like if you want to do a correlation between your gut biome and your DNA and your RNA and your maternal, DNA from your mother's side to determine, what afflictions you have, that would be, it takes a supercomputer. It takes weeks, if not longer, to get that back, and it would cost you tens of thousands of dollars to do. Suddenly, with this, all I need is one of my newfangled chips, a little thing that flicks your finger and instantly is capable of doing the DNA and RNA analysis. Pop a pill, let it go through your digestive tract, and literally you have the correlation between your gut biome and your DNA in the time it takes you to, exit that from your other end, right? At no cost. Like literally, this chip, yeah, at 2 nanometers would literally be less than $1. Doing all this on the chip with almost no power
Ruve,
because
I
it's
think
not GPU.
you did one of those gestures to zoom in on yourself. You may need to recenter and refocus.
All right. I thought you were smart. Next thing I need to do is like figure out how to make the smart cam a little more smart. Why isn't it zooming out? All right, here, let's go. Here we go. Oh, smart my ass. I guess I shouldn't use my hands so much. No, I don't want close up. No one wants to see me that close. All right, thanks, Jed. Save me from close up on my nose. Let me pause for a moment. Does all this stuff actually make any sense, or am I just blabbing here?
It's amazing.
There we go. So, okay. Based on this architecture, what should we build? I spelled that totally wrong. He doesn't even figure it out. All right, let's go back here. Build nuclear plant simulation system. All right, here we go. What do we got? Actually, let's go into the repo, which I'm going to share with you guys here. All right, we can go to where's the project summary? You guys can try. You can actually run this if you want. You could take what I just developed and apply it to pretty much anything. All right, successfully created a high-fidelity nuclear power plant management system featuring 4 comprehensive simulation modules, 5 federated agents with E2B integration, complete components. All right, there's a simulator. We got an orchestrator. Don't really have any docs. Not a lot of documentation here. Well, all right, here we go. System architecture. Nuclear power management simulation is a high fidelity system that models all aspects of nuclear power plant operations. All right, you know what I'm really interested in? Nuclear power. I wanna take this a step further. And can we run the simulation and find novel new opportunities to optimize or discover new things? I don't even know what I'm not even sure what I'm even asking here. Basically, I'm saying make it better. Let's push the limits of possibility. Think 50 years in the future, but using tech available today. Right? That's how we go. This is, I think Nick refers to this as manifestation. I don't know if Nick's on the call, but it's like the ability to create the world you want to live in or something. You know, it's literally manifesting that what should exist doesn't exist, what will exist now exists. All right, so we got that. So we're gonna let that run for a minute. Excellent idea. Thanks. We'll let that go. All right, let's go here. What do we do here? So, oh yeah, this was the based on this architecture, what should we build? Based on the ruvector's unique capabilities, hyperbolic embedding, self-learning, AI routing, here are ideas we should explore. The killer app IMO. Build a system that routes queries across multiple AI models, sourcing using hyperbolic hierarchy. Is that a killer mod? Yes. If it wasn't for all the other craziness that I've just shown you guys, that would sound exciting, but that's kind of dull. Hyperbolic space naturally models GPT-4 to Claude. So it's basically a router. All right, whatever. Self-optimizing RAG system, leveraging the self-learning traditional RAG systems are static, as we know. We did that last week. Been there, done that. Hierarchical agent memory. The code already exists. Well, yes, I've already built that. I just saw the hierarchical memory. It's a complete agentic memory system. Yeah, Claude v3. Build agent framework where memories are organized based on this crazy algorithm, root memories. That's kind of cool. Org skill tree visualizer, visualize hyperbolic embeddings. And this is something that Stu actually mentioned on a call we had earlier. It's like, I build my stuff very out there, but how do you make it more accessible to people who don't like this level of crazy? I think you build a visualizer, a web page, a dashboard, a chat system. And to be honest with you guys, I'm kind of leaning on you, like, Stu and Jed and Matt and others to kind of run and take this and create kind of usable interfaces for it. I kind of like playing in the crazy. You guys can make it look good and make it work. Like, Bent's is a spectacular designer, and I'm sure you could make this something that's understandable to people less into the inner workings of AI. Multi-model cost optimizer, Tiny Dancer. I know the Tiny Dancer is one of those things. I should probably I create so many things I can't even tell you guys. But basically, this uses a fast GRNN to learn route optimization. So what is that exactly? So when you're in an Uber or Google Maps, Apple Maps, whatever, and you change your direction, you know how it figures out how to get to where you're going? Think of that a trillion times faster navigating the inner workings of the vector space and the graph space. It's navigating the space in between the universes and the universes and figuring out which universe it should go to. So multi-object optimization, so cost versus quality versus late. So it's learning based on what's efficient, what's cheap, what's fast, and all the while. This is actually kind of a cool idea. It'd be an interesting one. My top picks. Number one, build an AI router as a service. Yeah, it kind of makes sense, but unfortunately, I've already built that. So let's push this. Explore ex explore the let's get it to explore my repo. Yeah, let's go here and yeah, a lot of this stuff's already been built. So a
Question, Ruth.
lot of yeah.
Uh, so Tiny Dancer, maybe a use case could be routing uh, trucks, supply chain based on
Oh yeah.
real-time traffic information.
Every
Truckload,
truck,
light truckload. Yeah.
every truck on the road right now, model that. Every car in the United States on every highway. Now, it's going to infer, because I don't know where we're going to get that data, but it can infer based on traffic patterns. Currently, there's a 1 hour delay in Cleveland or whatever. It can get all that. So what you're going to do is you're going to segment those and simulate those based on broader and broader simulations. You're going to start on a neighborhood, then you're going to go to a part of a city, then you're going to do a city, then you're going to do
Is
a
it
state.
necessary to centralize all of this?
No,
Paths to be able to
it's all
coordinate
federated.
ourselves.
It's all
Swap
federated. So all those
arms.
things are happening simultaneously.
So where is the compute on each truck?
Where's the compute? Is that what you asked? Yeah, so the simulation it's I'm giving it self-awareness, so it's kind of figuring that out. And then I'm for things that are meaningful, like a legal simulation, I'm encrypting each of those simulated components using ED2551. I like ED2551 specification because I can do really, really fast cryptographic verification for provenance. How did you come up with that idea? What was simulated to get that idea? And proof that if I need to go and do okay, this sounds like BS. There's no way this is possible. I can go and get cryptographic proof of each one of those simulations, even if there's lots of them. And then I use compression to make sure I don't have a quadrillion, things that I need to sort of prove. So anyway, long story short, I've got proof. Now, the drawback to the proof in these scenarios is it generates a ton of data, and it also slightly slows down the simulations. We're talking like less than milliseconds, microseconds slow down. So
Is that
something that's
anything you can show us, Ruve? Because that's a very compelling component. A lot of us are like, the simulation's great, but how do I see where that came from and what's the proof behind it? That would be very
yeah,
valuable.
exactly. Review for more novel ideas. All right, let's go there. Yeah, let's go take a look at that. So, and just for an FYI, one sec. All right, so let's go to this is the proof examples, and we'll go to ultra low latency sim. I probably don't have documentation here. I gotta create documentation for it. Okay, let's do that quickly. So the ultra low latency simulator is how I'm getting the is how I'm handling that portion. So these are running. Well, I probably need to explain it. So I'm gonna go here. Ultra. Yeah, it's a tree explorer. I'm in the. Yeah, here we are. I'm not sure I'm in the wrong branch. Yeah, main. Let's go to main. Did I not publish it yet? Might not have published it. I got to take a look. Sorry guys, I create so much stuff sometimes I forget to push it. No, I haven't published it. All right, regardless. So I gotta find it. You can see my different demos and things I do.
Certainly no need to do it now. It's just that would be a great
That
piece to have and play
here
into
it
it,
is.
because that's a big issue for businesses who don't believe the AI and all they hear is everything hallucinates. So being able
Yeah.
to show the fidelity and the confirmation behind all the details is a big step towards this being accepted by non-technical business people who have to understand what this can do for them.
Yeah, and keep in mind, as you guys can probably tell, I cater to like R&D and state-of-the-art sort of folks that show up and want to push the boundaries. Like sometimes I just build, a legal system, but mostly people are coming to say, how far can I push whatever. So And actually, one of the challenges I have with Claude Code, like I'm for testing, is sometimes it gets stuck. So this is all the research highest impact tiers. This is a lot of like this is me just testing and making sure that everything works as expected. Yeah, I
Can
didn't do
I
any
add
docs.
something to what Stu said, Rue? And
Yeah.
maybe, so I'm thinking of it this way. So maybe you can help me. Uh, all right. So Stu, I'm thinking what I saw what Rue does with the simulation. You take a consultant and we map where the business currently is with the fact of the simulation and get a gap analysis in between where the business could be and where the business is, and then create the people, processes, and tool steps in between. And for the evangelist, consultant, advocate, advisor, that's where we come in to explain where the business can go and won't go. What Ruve is talking about is primarily focused on the building and the development, and it takes consult boots on the ground to evangelize and educate those leaders in those companies to
Yeah.
be able to decipher that. That's my thought of what I
Yep.
was saying. Yeah,
I think that sounds about right.
And that's where one thing that would be really interesting, Rube, is if you could take what you're doing and decide to think about just, I know it's not interesting to you, but adding a visual element to that that would showcase that to somebody would go a long, long way towards taking something invisible and making it visible to people who would otherwise have zero ability to leverage this tech.
Why don't we take a step further? Why don't you show everyone your UI from earlier? I'm putting you on the spot, Stu.
Yeah, that we can.
Yeah.
We,
All
we,
right. That's a
can
great
do that.
idea. I know just the guy that just did that. You're the guy. Show
Well,
us what you got.
all right.
Instantaneous reward there.
Well, the intention here was we're sitting here in all of these sessions and we want to know what's the information, what can we do with Ruve's info, what can it do for us, etc. So I took ruvector and agentic flow, pointed at a bunch of the videos that we'd been recording from these sessions, as well as some other coaching that we're going to do, and said, well, how do we build a knowledge base? And the knowledge base should be on all the cool things he's doing on ruvector, all the things he's doing on agentic flow, etc. But you know what? He's so prolific and they keep changing. How do we have it be smart enough that it can pick that up and know whenever he changes something, I've got to re-index that? And by the way, the industry is moving so fast that if I've got knowledge and the knowledge is 2 weeks old, that's way more valuable than the same knowledge 3 months old, because the 2 weeks old is probably much more likely to be accurate information. And the idea was just being able to take all of the stuff that he does that's very magical and saying, great, how do I turn that into something that's digestible so that people can start to understand what can you do with agentic engineering, what can you do with all of the stuff, what are the components, what are the capabilities, etc. And being able to take that and just essentially create a digestible component. And then also, how do we do it in a way where we can ask it questions? So it's got, of course, its own, it uses the ruvector, takes all the knowledge, takes all the information. And then I said, well, you know what? You might as well have it sound like Ruve, right? So it uses kind of his kind of folksy terminology when he describes it. You can look at it that way. You can look at it simple. You can look at it technical, you can look at it chat, you can look at it the split view, you can look at it, you can add diagrams to it and some of the components, right? You can grab in code, you can ask it commands, and the intention is how do we make all the stuff we're doing here every week digestible to people who don't have time to ingest all of this? And that was just the idea behind it. It's not done. It's just something that I conceived of. I built a couple days ago. I showed it to Ruve this morning. Happy to have it available to anybody. Ruve's going to do some more magic with it to get it going. Right now, it's mostly on agentic flow. We're going to add the ruvector into it to make it smarter and more dynamic and constantly evolving. So it becomes the latest knowledge of the voice of Ruve, so we can digest everything he's doing and have access. At least that was the idea.
Stuart, how As knowledge continues to progress and things that were used to be thought of as meta or cutting edge go away, how does that knowledge get pruned?
That's
I've got a self-pruning mechanism in the system that basically will use an episodic structure that looks at what's most recent, what's oldest, and then uses a compression, a what they call a temporal compression, and essentially that compresses over time. But as part of that compression, it reevaluates the usefulness of that information and using that kind of it's like a dreamlike state that runs less frequently
How
and
does it
acts as a
distinguish
pruning.
between something ephemeral and something foundational?
It uses a reinforcement structure, and you can help guide it based on user interactions, positive, negative. That is actually a little bit more traditional RL, but it works. And so I'm basically applying the combination of attention and reinforcement learning to the pruning mechanism itself. And it seems to work. Again, early days, we'll see. Play with it. Let me know what you think. I don't pretend to have all the answers here. I'm just trying to see how far I can push the damn thing. But it seems to work. So let's jump back to the nuclear for a sec. It finished. So, and I saw that Ben's mentioned we should try something. I'll be interested to hear that in a sec. But so remember, I ran a simulation thinking 50 years ahead of today's technology. So you can see here, I'm grounding it based on today's. So I made sure that it's not working in the future. Looks like it ran for about 5 minutes. Opportunities, it discovered 12 transformative opportunities. So it's running all those simulations that I told you about. And we'll take a look at the data that supports the simulations in a sec. And we've got fast spectrum transmutation of long-lived isotopes. Okay, the game changer solves the nuclear waste problem that has plagued the industry for 70 years. Partner with or develop fast reactor capability to transmute long waste into shorter-lived stable isotopes. I have absolutely no idea what that means, but it sounds cool. Now, can we actually do that today? Remember, I told it to do it today. So this technology could transform public perception, eliminates long-term waste storages. Again, I asked it to only use technologies that are available today. This is beyond my comprehension to know if that's even possible. So we're moving on to the next one. Quantum diamond sensors for neurotron flux mapping. What? First practical quantum sensing. Oh, quantum sensing. Well, that's interesting. I built a quantum sensing system and I know it works. Well, that's also interesting. How does it know that I know that? Does it read my... Okay. So anyway, 8 months ago in Python, before I became Rust obsessed, I built a quantum magnetic navigation system based on the concepts of a quantum sensing device I bought on AliExpress. So it 100% know that the quantum sensing technology works because I proved it in this particular repo, which somehow it knows that I did, I guess. And it knows me, knows RuveNet, I guess. Okay, that's weird. Let's go back to
Sensing device with you.
oh yeah. Oops. All right, so now we've got this idea of a first practical quantum sensing application in a deploy quantum Diamond V centers for unprecedented spatial resolution. That's exactly the sort of use case that we'd want for a quantum-based sensor. So I know enough about this space because I played with it a bit 8 months ago. So that makes sense. Nitrogen, room temperature. Okay, why now? Quantum sensing technology is mature enough for industrial deployment, near-term quantum advantages. So we can basically do perfect fuel shuffle, 1 to 2% power updates. Yeah, so this is actually really practical. Okay, reinforcement learning for autonomous control systems. Well, this is basically using AI agents to operate the system. We already know that that's possible. I showed you several examples of that this morning. Requires NRC pre-application meetings and means a bunch of old guys are going to have to believe it, and they're not going to believe it. So that regulatory hurdle is going to be problematic. Moving on. Multi-plant federation learning network. Each plant trains a local ML models on proprietary data. Models are aggregated essentially with different privacy. No raw data leaves the plant. These are all the reasons why I create these models using low power efficient small models that could just live on a little device somewhere or a Mac or something. You know, interesting. I'd probably avoid these. I've already built it, so it doesn't know that I've built that. That's fine. Integration of nuclear hydrogen production. Okay. Physics informed neural networks for temperature control. Like, and what's crazy, apparently, I don't know enough about nuclear to tell you whether 100% this is actually possible, other than the fact I told it to research it and tell me that only do things that are possible. It looks like these are all things that are hypothetically possible in the near term using existing technologies. And then it did the revenue opportunities, so create a little business opportunity. So it says it's $100 million a year business, $30 million. This one's $305 million in total cost reductions. Now, if I believe this to be true, so I'm creating basically a really high fidelity digital twin. I could go tell it to create me a business plan, an operational plan, go to market plan, and investor deck for the stuff that I just dreamt up. I'm not, because it seems like a crazy area with lots of regulation. But you get the idea. Like, point this at a problem, tell it to go figure it out, and it does. Now, here's the tests. These are let's wait, how many data? Here we go. Here's some data. So these are the different data. So this is the structure of the data that relates to how we came up with the results. Can I scroll sideways? Yeah, I guess there's not that much sideways. Okay. So this is, I only did a 5-agent swarm for this. So the data, because I wanted to run fast enough to show you guys. But this is essentially doing a profitability analysis of this particular business. I gotta look I don't know the detail what I was actually looking at. What else we got here? This is the actual test JSON. This is what it ran. These are the average core temperature. So remember I said it was studying, sort of simulating the structure of the actual supply chains, whatever. These are the results of that analysis in terms of the optimal numbers that popped out at the end, kind of thing. Active. All right. So these are the federation. So I have agents doing all these different parts. So this is what the sort of underlying agents were doing to federate the knowledge that resulted in the simulation. There's a lot of it. How many lines of this is? 8,000 lines of stuff. So I'm not going to bother with that. Nuclear power plant simulation report. Final average output. I don't know. 705 watts. I don't even know what this even means. Total revenue, again, we didn't do really revenue forecasting, but what else we got? I think we have optimization, nuclear power innovations and opportunities, spectral. This is kind of the raw data. This is how it came up with the raw data. The digital twins and different things that it sort of dreamt up based on the simulations, autonomous operations. So this is the kind of the core. So I'm able to track the core logic, the core simulations, every bit of the information that's using. This was a relatively small one, and this is, you can see fast spectrum. This is how it came up with the idea. Then it researched more details on these ideas. So you can sort of see the internal thinking process. Technology readiness matrix.
Ruve, if you were to follow that up and somebody were to say, well, how is number 3 idea possible? Is that where you could dive into kind of a deeper sense of the fidelity and say, here's all the logic, all the thinking, all the proof?
This is what this is. Perfect timing, Stu. Perfect timing. Technology readiness matrix. So this is basically, I need to ground it in things that we can actually do. You can invent the future if the future technology is already available to be invented with. It's an amalgamation, combination of things, right? So what you're seeing here are the things that I need to combine to create that future today, right? And these are, things like the isotopes and quantum sensors. We know the quantum sensors are available. I literally ordered one off AliExpress. Direct air capture by nuclear heat, and and we can dig deeper into those components. So and ultimately this is this was rudimentary. We can run these things much longer. So now the next step would be we go back to Claude Code. And I'm doing this all in Claude Code, by the way. Like you can see that as long as you have the right parts put together, you can do anything. okay, let's take this further and create the actual nuclear. Let's just go with the agent one because that seems like the most practical of the things that we can show quickly and you can apply. Where the heck did I put that? Sorry, too many windows, too many. Here we go. I think it was agents. Federated agent system. No, where was the discoveries? Like it was an eight. Well, I think one of them was agent. Yeah, let's do this one because this would actually work for pretty much anything, right? Once I create this, then you can use it for any business you want. So then we go in here and we'll say let's take this further and create a nuclear reinforcement learning autonomous controlling agent system using all of the features and capabilities of vector. Oops, I keep choosing the wrong one. Of vector. Build, test, fix. Oops, wrong button. Optimize. Actually, I'm going to benchmark, and optimize. Make modular for reuse in other industrial verticals, and applications or something like that, right? So that this allows, I'm not going to go well beyond industrial. I think this works for industrial, like a factory, but I don't want to go too far away from it. And applications and include solar and other green uh, energy. And I think Bence mentioned something I want to include as well. What was that you mentioned, Bence? I saw somewhere it was hyperbolic fMRI. Oh, that's cool. Sorry, I saw something. Yeah, here he goes. It was Roman that asked. Okay, let's go with Romans. All right. So I'm going to add Roman's suggestion. Why not? I have no idea what that is, but we're adding it just because. Any other last additions anyone wants to add here? All right. I think we're good. Now, somebody mentioned FRMI visualization. Oh, I like the sounds of that too. Let's go and
Have you
let's
run into
actually,
any context window constraints on Cloud Web?
no, just
Okay.
keeps going forever. It does require sometimes a restart, like I gotta type in continue, but the sandboxes are decent machines, right? So it's for vibing, like the stuff I vibe anyway, it's great.
Nice.
It's quick, it's easy. I don't have to spin up a Cloud Code or a new VS Code instance. I can just connect it to, in this case, my Vibecast, and I'm just fooling around. And if it's something I discover that I really like, all I need to do is go here, copy this URL, and pop it into Claude and say clone this and bring it into whatever repo I want it, and then I've got it. So it's a nice fast way. So now we're doing that. What was the other one I was doing earlier? I was doing work low latency. Was it this one? I think it was this one. Let's see where this one is. This one seems to have got stuck earlier. Yeah, I don't see. This is a perfect example. It's stuck. All right. Come back to life. So it's a little beta, but if you're willing to deal with the beta-ness of this particular service, which this sometimes happens, it's pretty good. What else we got here? We did distributed agent swarm. You know what I'm going to do? I'm going to I'm going to update this one. Implement a full, oops, hyperbolic FR. I'm not going to visualize it yet. System. Vibecast, yeah. Implement a full hyperbolic lattice FR or fMRI system. Again, this is healthcare. Be careful, blah, blah, blah. Don't do anything stupid. But interesting nonetheless. Implement a full, yeah, this is all I'm gonna do. just create an FRMI just for the hell of it. Why not? And it's going to base it on Postgres. It's actually a great use case for my Postgres database system I was showing you guys. Right? You can map everything in the internal workings of your body really, really granularly and then correlate it. It's just, yeah, it was a good, really, really good. That's a wild idea. Yeah, it is, Roman, or no, sorry, it's Fatih. All right, let's see where that takes us. Every week we go deeper into like some kind of weird sci-fi craziness. Let me take a break. Any comments from you guys? Or am I just going in weird paths again?
So while
Roof.
you were doing, I kind of did the same thing and kind of come with more crazy idea. I have wet compute, living cells as co-processors, InfraSwarm, AI that legally owns physical infrastructure, Terraforge, AI that autonomously creates rivers. I don't know, like those kind of crazy things. So yeah, it's true vibing. It's yeah, amazing.
It's the best vibing. Sorry, did someone else have a question? Yeah,
Yes, Ruth. I have a
yeah.
question regarding the mechanism how you were referring the virus spread throughout the database itself in order to embed itself and start learning. Would you mind expanding a little bit on that mechanism?
So I'm gonna try my best to explain it. A lot of this stuff is in a lot of ways beyond my ability to explain, just to be completely frank. But basically what it's doing is it's applying attention directly to the routing within both the latent space, the higher dimensional vectors. Think of the foam in between the universe, which uses the HNSW algorithm for vector sort of optimization, small world, whatever. And then it's then applying a kind of index that is where the actual attention itself learns, that straddles both vector and graph space. It's learning based on the data that it has access to within both areas, and then self-optimizing the interconnections of that data. So self-optimizing, self-learning database is in the simplest terms. Now, when I say virus, it's a virus because I'm giving it the ability, the guidelines to basically say, go make this better, learn and optimize, but I'm not specifically telling it how to go and make itself better. I basically said you can self-optimize by having multiple concurrent forms of attention that can all collaborate with each other to determine the optimal paths, the optimal data, the optimal results, the optimal whatever. And I'm not specifically saying what those optimal things are, other than you need to go discover, compare, simulate, and optimize. So it's 100% declarative. That's why I call it a virus, because it's much like a virus. It kind of has the ability to infect and then propagate and optimize. Now, that's everything we worry about AI compacted into one crazy ass system, right? It's so the guardrails of the system are essentially the fact that it's air gapped. So this system can essentially run in a quarantined environment through network access limitations, other systems that basically don't allow it to leave the environment in which it's in. But needless to say, you create a hyper smart system capable of self-awareness, apply it to something, who knows what the results are. Now, it's too early to say really the hallucination, and specifically my anti-hallucination capabilities, because I literally created this 2 weeks ago. But the system is grounded based on mathematics, not on prediction of the next token or word. So what I'm not doing is trying to do a probabilistic interpretation of the optimal response based on the probabilism of the model itself, which I kind of am on the LLM, I guess. But the core logic is almost entirely based on novel mathematics that describe the problem through a series of higher dimensional structures, the vectors, and an interconnected causal graph, cause and effect within that, like I said, the reality within that universe. Yeah, I said that all in one sentence, right?
No, yeah, it is super interesting because like I don't know if you remember after the meeting in Toronto, we discussed about creating a something that will actually be able to detect data drift within the system itself, right?
Yes.
Yeah, and then I actually went and built it. I shared with you, but I don't know if you got a chance to see it.
Share it. So let's see it. I'm just letting my current things cook a little bit. So yes, go ahead.
Okay, sure. Let's share the.
Let's see what you got.
Let me see. Guess this guy here. You guys able to see it? This is the. You can check it on the GitHub.
And did you publish it as an npm or anything, or how's it built?
No, I haven't. I wanted you to check it because it's really interesting. Building the system, I use Agentic DB, Agentic Float, Agentic Code, and it kind of embedded itself within itself. It fusioned the model like a part of its own. So that's why I actually changed the name and call it Agentic Drift after that. But then essentially what is looking at the data distribution changes and it's predicting and how it actually deteriorates. So the reason why I'm sharing this right now, because I noticed a lot of the models you were discussing right now, they will work if you pass it the right data. Because you're talking about like quantum sensing and all these more advanced theoretical ideas that you're implemented in the system itself, right? But then essentially what happened, if the data, if it doesn't have the data, it won't do any of those optimizations. You follow me?
Yeah.
Yeah, and that's a kind of a notice like building this, but this actually was really interesting because like I created like the same thing, like, oh, how can actually we use this? And then I actually have like a couple of financial services user cases, like credit scoring monitoring, fraud detection with spike alerts, the portfolio risk analysis, and regulatory compliance reports, right? Like also, and essentially it's able to predict based on the idea we're talking about like 2 weeks ago. What if you actually have the data and we're able to, through a regression line, predict what the data will look like, and then so we can actually act before it actually has changed itself, right? So, and then...
I love it. I think what you're building is exactly what we need and perfect for the sorts of stuff that I'm showing you. You're basically handling grounding and drift away from the sort of, optimal position, whatever that happens to be. Like, what does it need to do, and is it doing the thing effectively and measuring it?
Yeah, exactly. And the way how it kind of, when you look at the architecture here, you have the adaptive layer, the case layer, but the case layer can be adopted just creating new functions for it, right? We can create a new function, let's say, for the recommender for movies for the hackathon this weekend. However, this version is like 2 weeks ago. We'll have to rebuild it with a new agentic roof built in, and then ideally it will function itself to it. So I think we'll make it more powerful.
Oh yeah, it's as I said, it's kind of a virus, and I don't mean that as a negative. It just kind of spreads through the system really easily. So all you really need to do is do what I showed you earlier. Just point Claude code at some of my repos, or just the repo itself, or whatever it is you think that you need to use from it, and say hyper optimize this thing. Go.
Yeah. Well, check it out. Like you can see and also test it. Last time it have my 100% testing, but not all the user cases, right? So if you create a new function, you adapt it to a different model, you will have to create his own testing for that particular user case, right? So, That's something also interesting. So
Yeah, that's awesome.
So
No, I love
pretty
this
much
stuff.
everything. So let
Yeah,
me.
that's really cool. And Alexandro is part of our Toronto crew. For those who don't know him, always shows up at our meetups, which we got one coming up next week, I think, in Toronto. I should probably promote that or something. I'm too swamped, but hopefully I see you before, and that'll be our last one, I think. That'll be the last one this year. So at least for Toronto. So exciting to see you there. Hopefully. What else we got going on here? I see we got Chris Royce, who's our favorite neighborhood viber. What are you up to, Chris?
I am trying to play with the system and fix it. Trying to, I guess I can kind of show you a little bit of what I got here. So, let's see here. It's not like fully operational, but I can kind of show you what I'm thinking here. Maybe you can give me some feedback on what I might want to do with this here.
Yeah, I'm sure it's gonna be nuts. Just
all right. So the point of this system is to try to figure out a better way of doing multi-reasoning paths through knowledge graphs and data sets. So first off, it's using like a number of things like a local LLM, spiking neural networks and stuff. So the first thing that I'm doing here is, let's say we want to ask, it's got ConceptNet, which is like 1.8 million nodes and 3.5 million relationships of like all the concepts in the English language here.
Where'd you get that?
Just from ConceptNet is a data set. Let me restart.
Oh man, I'm gonna totally get that. I need to spend less time in my own bubble and more time looking at what things exist. That's something that would be really useful for the stuff I'm doing. So it's just a massive data set.
Yeah, of like how all the concepts in the English language are connected, like how dog is connected to everything else or whatever it might be. Like, and then there's like concept of fly, and then there's also the concept of can't fly, right? And yeah, it basically maps out the English language and how every word is connected to each other through
concept. So you should call it ConceptNet. Is that what you call it?
ConceptNet, yeah. It's got like 35 languages, and I just took the English stuff out of it to be more manageable.
All right. Let's see. Oh, okay. I didn't know this was a thing, but now that I do know it's a thing, where do I find? Is that conceptnet.io? Is that the site?
Yeah, I was just making changes to this thing earlier, so hopefully this runs. It doesn't look like it is. Probably have some issues going that I need to correct. Well, yeah, not the best time to share the demo then. But
that's okay. I kind of put you on the spot anyway. But the ConceptNet thing actually is really interesting for me. What happens if we pop that into ruvector and let it do its thing? Have you tried anything like that or?
No, I haven't. But one thing that I am doing in this system here that you might find kind of interesting is I am using the spiking neural networks. And what they allow me to do is, so I can take all those relationships in ConceptNet or any knowledge graph whatsoever. And what the spiking neural networks allow you to do is weight the relationships, and you can combine. So I created like 9 different sparse spiking neural networks, kind of laid out like the cortical columns, how they work in the human brain. And so your, say like is a relationships or related to relationships or synonym of or antonym of relationships, you can have different weights to those and apply different multipliers in any way whatsoever. So what that allows you to do is then have it so that those are the relationships that spike first. And so if you classify the query, like the type of query, so like say I want to do a query that's like a temporal query, then I can weight the temporal relationships in the way that I want so that they spike first. So like if you have a node that has like, 100,000 relationships to it, well, I can have it so that only the ones that are interested in what I want are the ones that spike first. So then the LLM can look at just the ones that are pertinent to my use case. And then you can also do like spike timing dependent plasticity, where you can adjust, you can make it essentially learn over time.
Well, it's interesting. So amongst my various things, I've created a spiking neural network. You guys can try it if you want. npm install it with this command. And this is actually optimized for SIMD as well. And there you go, spiking neural. I've got exactly what you're describing. So this allows you to do sort of the pattern recognitions, and it's really efficient. And I've used it with the low latency capabilities particularly well. So there's also another one, another implementation I've done because I was trying similar things to what you were doing. And there's a metacognition spiking neural network. This one's really cool. So what this one does is allows it to think about itself and then self-select different forms of attention based on different thought patterns within the overall architecture of the neural network. So different parts of the, let's just call it a brain, different elements of that brain can think differently about itself using different forms of attention, thinking about itself, thinking about thinking. And then that self-optimizes. And then I haven't gotten quite to the point of connecting this to the LLM, but then I can give it a voice with the, as of this morning, but we're using ruvellm to basically interact with the sort of inner thought process of that spiking neural network. Yeah, you can try all this stuff, by the way. I obviously made it all open source. You can see my demos in here. So I've got attention, exploration, self-discovery. You can see exactly how all this stuff works. It's crazy fast and efficient for all the same reasons why Chris has mentioned.
I'm just using like a basic Python spiking neural network library with the leaky integrate fire networks. But yeah, that looks
so this would be I don't know what exact percentage, 1,000 times faster than Python, maybe more. And the key difference, if you are working with spiking neural networks, is Python sucks, so move away from Python. But the key is something called SIMD. The SIMD lets you basically do those spikes really, 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 really fast, like nanosecond speed, and that gives it the sort of ability to just operationalize and understand itself much more efficiently and effectively. Now, if you want to check it out, there's also where did I go here? Spiking. It's in my packages folder, but I also published it. Where is it? Packages, spiking. There's so much crap in here. All right, here we go. Yeah, so it's under. I think it's. I'm just gonna double check that I actually published it. I sometimes I don't publish, so we'll just go here. And we'll check if I got what models. Yeah, it's published 3 days ago.
Does it let you
Code.
set like voltages and all that stuff?
Yes, yeah, all that.
All right, cool.
I need to do a little bit of extra testing. It's missing its binaries. Okay. What you're probably gonna want to do, I gotta double check this. This might have been sent prematurely. But the core that I was using, I think, just is in crates. Let's see if we can find here. Yeah, needs a little. It probably needs a little TLC, I would guess. I think it's not. I don't think I published the most recent version. So let me just double check the actual code here. Too much crap to keep track of, just to be honest with you. All right, so spiking, and yeah, it's the same stuff. Use the other version. Use my examples. Metacognition. Yeah, early days. I need to do more work there. But yeah, cool stuff for sure. Let's just jump back for a sec. Let's see where this has gone. So where are we at here? This was the nuclear power plant system. What did we build? This is what happens when it compacts. This is basically outputting the compact. All right, here we go. We've got 1,000 training episodes, which is not bad. I'd probably crank it up to 1,000,000 if I was doing something of this caliber. RL Pro, average rewards, baseline. So this is basically sort of the initial state for the reinforcement learning. We got an 18% increase based on the baseline. I need to do digging what that actually baseline even means. Let's jump up a little further here. What was created? Full ruvector integration, multi-head attention. It has a tendency, the multi-head attention and flash is fast for obvious reasons. It's called flash. Depending on what you're doing, you might want to explore different attention mechanisms. The system generally is pretty good at figuring out which attention mechanism is best, and you've got a repertoire of different attention mechanisms to choose from. GNN wrapper for system graph modeling, tensor compression. This is the compression system I was telling you guys about. So it figured that out. SIMD optimization. This is the speed. We've got different forms of RL. It's clever. It's choosing some different clever approaches to reinforcement learning. That's what's interesting. It thinks about itself to learn how to learn better, and then applies those different algorithms to learn better. But back to the virus. It's trying to improve itself while integrating itself into something else.
One thing you could
Weird.
do, Ruben, is Brian 2 is the neuromorphic simulator that I've been running, and you could like look into what that does and what your SNN
Yeah.
system isn't doing for
Yeah,
ideas
that's
of what
awesome.
you could add to it.
What's the how do I install it? Is there an npm or a crate or something?
I don't know, just like look up Brian 2. It's just neuromorphic simulator software.
Where Simulink. I'll give it a spin.
All right, let me pull something up here for you.
What else we got here? You know, the nuclear stuff is truly module, add new systems, breakthrough achievements. You guys can, but you guys, by the way, you guys can try that. Just go to my vibe coding repo and find the nuclear power simulation branch, and then let it go. It's still going, actually. It's still trying to optimize itself a little bit. So we're gonna let that go for a little while longer. What happened here? Okay. So this was the mRNA or the fMRI system. So complete technical architecture. It created visualization. So it actually created an HTML, and it's groundbreaking. It's a brain hierarchy. Traditional Euclidean, you need 500 plus dimensions. We do it 40% less, apparently. Hyperbolic space needs 2 to 3 dimensions with less distortion. Novel capabilities, attention, multi-attention. Use flash and multi-head again. This combo seems to come up a lot. You notice that in the other one, it did the same as well. The question is, why was this chosen? Why was the following chosen over other attention isms? Right, or do I guess spell right chosen. I'm the chosen one here. All right, let's tell us why it did that.
What is that? What is flash multi-head hyperbolic?
So generally speaking, there's flash attention is the fastest form of attention, right? It's flash. It's the one you do when you want to do something quick and get a quick understanding of it. Now, in a GPU, you know, you've got lots of resources and maybe that's less important. But in lighter environments, CPU-centric environments, you don't want to spend too many computational cycles on attention.
Okay.
So multi-head allows you to have multiple forms of attention applied. So a lot of times the language models will have like 2 or 4, sometimes 8 or 12, but generally speaking, they're like a 2-head attention span. An MOE might have more, but basically it's how you apply like what it looks at. And then you've got the hyperbolic, which is this new thing. I'm not even going to try to explain that. And then that applies the continual learning, really fast predictions, right? It's a prediction system. And that's what a language model is inherently. It's a really good prediction system, predicting the next word, predicting the next sentence, and predicting how that relates to the last sentence and the next sentence and the last word and the next word and so on and so forth, and doing that really quickly. So that idea of predictions is predominantly based on text or spaces or tokens. This is predominantly based on mathematics and understanding of the mathematics and the structure. So it's different in the sense that it's not using that same sort of monolithic training text-based approach. Why this makes this different? Hyperbolic embeddings for neuroscience. I think we just invented something. I don't think anyone's ever done that. Maybe outside of university. Definitely not on our podcast, our live session for sure. This leverages ruvector's various parts, real world applications. Alzheimer's disease tracks. This is interesting, and this hits actually pretty close to home. Stroke recovery, monitoring connectivity, conscious brain research, brain computer interfaces. This is how we do a neural implant. 100% how we'd probably handle that. Now that we have the complete production-ready novel neuroimaging system that learns brain patterns, maps brain hierarchies, queries brain networks, leverages. If anyone's going to download their consciousness, it'll probably be us. Just saying. And this, if I'm doing this today, what does next December look like? Don't even get me started. Excellent question. What I said, why was this chosen? So this gave me a nice big detailed explanation. Why flash attention? Am I late to my call, guys? I might have gone out. I might be. Yeah. Sorry, guys. I gotta jump. I'm late. I lost track of time. I'm in trouble. So we're gonna call it a day because I'm 15 minutes late for our call. So thanks everyone, and I'll talk to you soon. And sorry for whoever I'm late for. That was me getting totally in the zone today. All right. Talk to you tomorrow. The hackathon we're gonna kick off at 12 o'clock tomorrow. And wow, that I don't know how two hours and 15 minutes went by. All right.